All right, so this is the old quiz that we used to give back when there was a chapter 5/6. So this will give you a good idea of some of the derivatives and integrals that you need to be able to do for our chapter 5 test. So find the derivatives. So dy dx, the rule for natural log is that it's 1 over u, and then we need to multiply by the derivative of 3x plus 1. So my answer for dy dx is equal to 3 over 3x plus 1. Same rule for natural log here. So y prime becomes 1 over tangent. And then the derivative of tangent is secant squared. Now you can leave it like this, or we can see let's see if we work on this at all. So 1 over tangent is cotangent. So that's cosine x over sine x, and multiplied by secant squared is times 1 over cosine squared. So yeah, I guess you could simplify this a little bit. But if you're just finding the derivative, if it's a free response question, it doesn't matter. Whether you simplify it or not, you will likely be plugging a number into that. You would only need to work on it if you don't see this in a multiple choice option, then start working on it and see what you're left with. For the next problem, we have a product here. So we have to remember to use product rule. So y prime will be first times derivative of the second plus second times derivative of the first. And I can clean this up a little bit just because it's actually shorter if I simplify it, less for me to write. So I'm going to say that's 3x to the third if I simplify that. And I like to put the algebraic term out in front, put the natural log last, so there's no confusion about what's inside of the natural log. Derivative of e to the u prime of x is e to the u, chain rule times u prime. So that will be 5 e to the 5x. Now, number 5 could either be really terrible or actually pretty easy. Really terrible if you just jump right into 1 over this times whatever terrible quotient rule would come out of this. Don't do that. And again, this would definitely be like a multiple choice. They're not going to have whatever crazy version that comes out of that. What you're supposed to do is expand. We've talked about this in the notes, and I've referenced it in a couple of the homework assignments if you've been doing those. And so this is natural log of x plus, it would be plus natural log of x plus 2 to the third. But remember, you can expand further with that little power rule. So this becomes 3 natural log of x plus 2. And then minus, because I'm in the denominator now, the square root is a power of 1/2 that's going to come out front. Natural log of x squared plus 1. You're not able to expand the sum inside of a logarithm, so those have to stay. But now the derivative is much easier to find. So now it's just the derivative of natural log x is 1 over x plus 3 times 1 over x plus 2 minus 1/2 times 1 over x squared plus 1 times the derivative of x squared plus 1, so times 2x. And so I'll clean that up. So 1 over x, I'm not going to do a common denominator, plus 3 over x plus 2, minus, these 2's can cancel, so minus x over x squared plus 1. Okay, now this one here, it's a power rule, and then it's the inside. Sometimes that throws some of you for a loop, I've noticed. So the outermost function is power rule. So something to the third power is 3 times that thing squared. So the inside of this stays as it is. And then chain rule says we multiply by the derivative of e to the x minus e to the negative x. We had something like this in our notes. We've had it in homeworks. So again, this should look familiar. If you're not doing the homeworks, you need to start doing the homeworks. Practice is what it takes to do calculus. All right, so this is e to the x I guess I didn't explain this because I was lecturing. So the derivative of e to the negative x is e to the negative x times negative 1. So my minus negative turned into a plus. All right. I don't think I'm going to really do much of anything to rewrite that. It doesn't matter what order you write this in. So I'm just going to keep it like it is and move on. All right. Find the antiderivatives. So this could be u sub. This could be trig. This could be inverse trig. This could be logs. Let's just take a look here. So when the denominator is 1 degree higher than the numerator, that's u sub, usually. So that means I'm going to let u equal 1/3 x to the third plus 8x. Du dx would equal 1/3 times 3, which is 1, x squared plus 8. Du divided by x squared plus 8 equals dx. Now, what do we have here? This is 2 times x squared plus 8. So looking at what we have here, we have the integral of 2 times x squared plus 8. We replace the denominator with a u, and in place of dx, we're putting du over x squared plus 8. So this can cancel with this. So u sub works as long as all of the x's that are left over after you subbed in for u, those have to cancel out. So we can take this 2 that's left over outside of the integral, and then it's just 1 over u du. That's 2 times the natural log of the absolute value of u, which was 1/3 x cubed plus 8x. Plus c, because this is an indefinite integral. So I will write this on the line. All right, for cotangent, I've said this before, I'm not going to have you integrate secant or cosecant because those are hard to, like, you just kind of have to memorize those. I will give you the integral of cotangent or tangent because I don't have this memorized. I probably should as many times as I've done it, but I just, in my mind, it's easy enough just to do it the long way. So what is the long way? If you have this memorized, go ahead and write the answer. It's either negative or positive ln of something. It will be ln of sine x. Okay, I know it will be this. I just don't want to think too hard about whether it's negative or not. So, but let me go into that. So let's just I'm going to put a circle here to decide. What if I don't have it memorized? I change this to the integral of cosine x over sine x dx. And then I'm going to do u sub. U is the denominator. Du dx is cosine x. Okay, so it's positive. Du dx is cosine x, so du over cosine x is dx. So the integral of cosine x over u, and then dx is du over cosine x. So we get it to this integral of 1 over u du. So yeah, that's going to be natural log of absolute value of u, which was sine x plus c. So if you want to memorize it, go ahead. That's fine. But do keep in mind, if it's cotangent of 2x or something like that, you will have to do u sub. So even if you memorize this, you do still need to make sure that there will be a constant out here for u sub. So you do have to figure that part out. All right. What about this one? I have a problem like this on our review as well. So what is the integral of x minus 2 over x plus 1? So it's definitely not inverse trig. We can do u sub, but then du dx is 1. So that doesn't get rid of the x minus 2, but we've run into this issue a few times now in different chapters. You can solve for x. Let's take this u equation and solve it for x. And then you want to have x minus 2, so if I subtract 2 from x, I subtract 2 from this side. So I can replace the x minus 2 expression with a u minus 3. And I can replace the denominator with u du. And the point of doing that is that you can then divide and say, oh, this is just 1 minus 3 over u du. And then if I integrate this as it is right now, I am integrating with respect to u, unless I really split this into 2 integrals. So I'm going to keep this. The integral of 1 is u minus 3 ln u plus c, ln absolute value u plus c. And then what is u? It's x plus 1 minus 3 natural log absolute value of x plus 1 plus c. Now, if you split this into 1 dx minus 3 1 over u du, like if you were dividing this out and then just saying, well, this is like if you do long division, you would just get 1 minus 3 over x plus 1. So if you do it that way, then this could be x minus 3 ln x plus 1 plus c. And these are equivalent. So I would take either or. The reason these are equivalent is because mine with the extra plus 1 is just a vertical shift of yours if you did it this way. And because the plus c can be plus any constant, mine's basically plus c plus 1. So that's fine. So I would take either one on that. It doesn't matter. For this one, integral of e to the 5x. So u would be 5x. Du dx would equal 5. So du divided by 5 is equal to dx. So that means when we rewrite this integral and it's e to the u, in place of dx, we're going to get du divided by 5. So I'm going to put a 1/5 out here. And that's 1/5 e to the u plus c. So e to the 5x over 5 plus c. All right, this problem says find dy dx. Supposed to be spacing there. Find dy dx, this is our equation. So because we can't easily solve for y, we will take the derivative with respect to x of both sides. I don't know why I didn't fill it in there. Okay. Okay, so the derivative of x is 1. The derivative of 4 ln y is 4 over y. Chain rule, dy dx. Minus derivative of y squared is 2y. Chain rule, dy dx. Derivative of a constant is 0. Both of my dy dx terms are negative, so I'm going to add them over to the right side, just so I don't have so many negative signs. That would make this like 4 over y plus 2y. And then when I divide it back over, 1 over 4 over y plus 2y. If you're just plugging numbers into dy dx, like if the next part is, okay, and now find dy dx at a certain ordered pair, you don't have to simplify it. But if you're looking for the correct equation for dy dx, you need to know that to get rid of this complex fraction, you can multiply by y over y. We did that a lot in pre-calc. That makes this y on the top. And then 4 plus 8, or no, not 8, sorry. 4 plus 2 y squared on the bottom. So that's what I'm going to call dy dx for this one. Y over 4 plus 2y squared. It's not wrong to have the complex fraction, but they wouldn't leave it like that if you're searching for a multiple choice answer. All right, here we go. Here's f of x. For x is greater than or equal to 3/2. Find f inverse prime of 2. Use calculus. That means don't try to find the f inverse equation. Just use calculus and then show all your work. There are basically 3 steps to these problems, remember. So if you're trying to find the inverse derivative, the first thing to do is set your f of x equation equal to what you're trying to evaluate this as. So 2 is equal to x squared minus 3x minus 8. Get that equal to 0. This factors. And it seems like I get 2 answers for x, although remember, x is greater than or equal to 1.5, so we can't use the negative 2. We're going to use 5. Step 2 is to find f prime at 5. So let's see. Let me find f prime first. So f prime of x is equal to 2x minus 3. So find f prime at 5. 10 minus 3 is 7. And step 3 is to know the relationship between f inverse prime at 2 and f prime at 5. So the formula is f inverse prime evaluated at 2 is equal to 1 over f prime evaluated at 5. Remember the 2 corresponding points on the graph. I know the graphs don't look like this, but the slope at this point is the reciprocal of the slope at its reflected point. All right, so our answer is 1 over 7. Same idea, but with a table. So this is supposed to be easier because you don't have to do math here. So for step 1, I still want to know when is f of x equal to 4 for this one. And that happens on the table. So I'm looking at f of x as an output of 4 when the input x is 5. And then step 2 is to find f prime of 5. F prime of 5 has an output of 11. And step 3 is to know the rule. F inverse prime at 4 is equal to 1 over f prime at 5. So 1 over 11. Number 14, find all relative extrema and points of inflection of this graph. Write as coordinate points. Label extrema as relative max or min. So there's a lot to do here. Let's start with the relative extrema. So that's first derivative test. So g prime of x is equal to, this is a product rule. So first times derivative of the second plus second times derivative of the first. Find the critical numbers, so set this equal to 0, and I'm going to factor out a 3e to the x, which would leave me with x plus 1. The critical numbers, e to the x is never equal to 0, so you just get x equals negative 1. And you need to put that on a number line to examine the sign, positive or negative, of g prime. So when I put in something like negative 2 into this equation here, 3e to the x is always positive. It's like 3 over e squared when I put in negative 2. But then this is times negative 2 plus 1. So that's negative. And then when I put in something to the right of negative 1, like 0, 3 times e to the 0 times 0 plus 1 is positive. So g goes from decreasing to increasing. So that means I know there's a relative min at negative 1, and then I haven't found the value yet. So what is g of negative 1? That's 3 times negative 1 times e to the negative 1. So negative 3 over e. All right, now the second part of this was points of inflection. So to find points of inflection, now let's go with this version of g prime. It's factored out, and then I can just do a product rule here. So to find g double prime of x, I'm doing product rule again. First times derivative of the second plus second times derivative of the first. Get the possible inflection points by setting this equal to 0. I can factor out a 3e to the x. That would leave me with 1 plus x plus 1. So x plus 2. And again, e to the x is never equal to 0. X is equal to negative 2. So I'm going to bring my number line up here for this. If we plug in something like negative 3, I'm going into my factored version. I would get 3 over e to the third. And then negative 3 plus 2 is negative 1, so that's negative. And then if I plug in something to the right of negative 2, like 0, I would get 3 e to the 0, so 3 times 1, times 0 plus 2, so that's positive. So g does change concavity from concave down to concave up. So there is a point of inflection at negative 2, and then what is g of negative 2? 3 times negative 2 is negative 6, e to the negative 2, so I'm going to say negative 6 over e squared. All right, now we get on to the integrating section. This integrating section is pretty similar to the 3 integrals I told you that you're going to have to do. Not the exact same thing, but definitely there's inverse trig on the 3 that you're going to have to do on your test. But they're like this, where you have an integral and you're going to write your answer on the side. All right, so we had something like this on our short quiz. You've got to study this rule. The integral of 4 to the x is just 4 to the x divided by ln 4 plus c. It's the derivative that's multiplied by ln 4. All right, so that's it. There's nothing else to do there. For this one, I have a constant over a sum of squares, and they're backwards. They usually are like that. That indicates arctan. So a is 3, u is x, du dx is 1, or just du is equal to dx. So when you go to set this up, there's nothing really needed for u sub or any of that. So this is just going to be 1 over a squared plus u squared du. And remember, the formula is for arctangent, it's 1 over a times arctangent of u over a plus c. So let's fill in the numbers that we have. So that's 1/3 arctan, which is the same as inverse tan, if you prefer to write that. I don't care. Over or of u over a, so x over 3, plus c. And here's another inverse trig. These are the only two that I need you to know, arctangent, and this one is arcsine. So when it's a constant over the square root of a backwards difference of squares. So a is 7, u is x, du dx is 1. So this is the integral of 1 over square root of a squared minus u squared du. Now, arcsine does not have a 1 over a. It's just arcsine of u over a plus c. So that's arcsine of x over 7 plus c. All right, now this one, differentiate. You can either memorize the formula, which I highly recommend, or you can do the triangle. So what if I memorize the formula? I need to know what is the derivative with respect to x of arcsine of u. It's equal to u prime over, use the integral to help you, u prime over square root of, not a squared, it's 1 minus u squared. Okay, so in our terms, u would be 4x. Du dx would be 4, or u prime, whatever. U prime is 4. And so you're just subbing those values in. It's just, okay, so it's, so dy dx is equal to u prime is 4 over square root of 1 minus, what's u squared? 16x squared. So formula, pretty easy. Triangle method, you'd have to say, all right, I'm going to take the sine of both sides. So this, if y equals the arcsine of 4x, then sine y equals 4x. And then you can make a triangle based out of that. The angle is y. The opposite is 4x. The hypotenuse is 1. Pythagorean theorem solves the last side. Square root of 1 squared minus 4x squared, the quantity, so 16x squared. That's the missing leg. And then you want to take the derivative with respect to x of sine y and the derivative with respect to x of 4x. The derivative of sine is cosine y, and because that was in terms of y, we need to chain rule, dy dx. The derivative with respect to x of 4x is 4. Cosine of y, I need a value for that. That's equal to adjacent over hypotenuse. It's equal to the square root of 1 minus 16x squared. I'm going to divide that to the other side. And I get the same answer. Triangle method, obviously more time consuming. The only time that the triangle doesn't work nicely like this is if there's a coefficient in front of the arcsine or the arctangent or whatever, but this would work for any of the inverse trigs. So especially if you get something other than arcsine or arctangent, which won't be on my test, but maybe the AP test, you could break out the triangle thing, see if that helps. Okay, so that was the last question that was on this old quiz. Hopefully that helps you, give you a good amount of practice. You can rework through any of our old textbook assignments, especially if you think you didn't do them as thoroughly the first time around. We also have another review and an AP classroom. There's lots of stuff you could be using to prep for the test.